Guten Tag. That's an appropriate greeting for today, since today we're going to be looking at the Rubens Tube, which was invented by Heinrich Rubin, a German physicist, in 1905, and it's used in acoustics. And just to give you a little bit so you can understand what to do with the lab, you'll see the videos that'll explain it in greater detail. A couple things you simply want to know. This pipe is closed at both ends. It's got a speaker on one end and it's got a cap on the other. So it's closed at both ends. We have symmetry. We haven't looked at ones that are closed at both ends, but it is symmetrical like an open pipe. And what you're going to see, flames that have varying heights. And I'm going to use the phrase segment to represent one of these, which is really from a node to a node, which really represents half of a wavelength. That's the key. But I use the phrase segment to represent one of those. So you're going to be counting the number of segments. Simply got to count the segments and write down the frequency, do some calculations. The pipe that you're going to see that I made was 180 centimeters or 1.8 meters is the length you're going to use for that. So, and we're going to be using methane. You have to use a flammable gas in this. So when you come to the lab, some things you simply want, you just fill out this chart. You should go really quick, watch the videos. The gas is methane. You could use other gases, but I used methane. And the length is 1.8 meters. That's going to be the same for all of those. And you're going to watch the video to get the frequency in hertz, not too terribly hard. This is the number of segments, okay? The number of segments, you just got to count. Got to count the number of segments. So you simply count. It'll be pretty easy to count with that when the frequency is set. And usually I take my hand off of it, and then you can tell, oh, that's the frequency we're going to use. So that's a number of segments. It's going to be an integer there. The wavelength, if we were to call this n, number of segments, the wavelength is, if you take n times the wavelength divided by 2, that would be equal to L. Okay, so in order to find the wavelength is going to be 2 times L, which is 1.8 for all of them, divided by the number of segments. So just 2 times 1.8 divided by the number of segments, that'll give you the wavelength. And then to find the speed simply is the frequency times the wavelength. If you've got the frequency in hertz and the wavelength in meters, then you'll end up with meters per second. That's all you got to know. Complete the chart and then answer the questions. Hope that helps you. Auf Wiedersehen.